Yeah, so a big part of this now is that, a big part of this is that in Ignition 8.3, how they're doing DevOps and how they've structured the files, as well as some of the difference in the gateway area network, some of the enhancements they've done there with protobuf and all that, on top of some of the complications of Sparkplug and using Sparkplug for all your tags and managing your UDTs through it and all that. You need the gateway area network anyway for a big part of it. So within the Ignition ecosystem specifically, letting Ignition talk to Ignition as Ignition and let it do what it does best as itself. So like for this architecture here, for example, we're starting at the edge here. So we got our asset controllers, typically going to be PLCs and things like that. From there, we're aggregating all those tags and doing some edge modeling a little bit as needed within Ignition Edge, just to kind of buffer up through the field. And then that brings us to the new part of this stack, is the tag gateway. This is where we have all of our tags. The main tag providers, historian, things like that is kind of where this is intended to be. Going up to your more traditional front end and back end architecture from there. So this is a basic scale-out architecture with the addition of a tag gateway for your tag providers and such. Part of what this allows then is on your front end and back end, you can have full DevOps life cycles without having to worry about losing the state of your tags. Specifically, if you have memory tags or anything like that, you don't want to lose those by restoring backups or any of that thing. So then you can do your full DevOps projects and such over here and over here without affecting the tags or production in any way, especially when you combine them with tools like Axelon or 4AR or anything like that, that can make it even easier to do the DevOps pieces. So then you'll see off of this, from the tag gateway out, so the responsibilities of the tag gateway are basically just to be your tag providers. This might look like a UNS to some, even though it's not an MQTT broker. It may look like we're taking a step backwards, but within the Ignition ecosystem, this is where you're unifying all your tag providers and you're unifying all the tags. Your historian goes off of here, and you are publishing to your actual UNS or your MQTT broker infrastructure from here as well. This is where we're going to do some modeling. One of the things I like to do in here is a unified tag provider. So you're going to have a bunch of reference tags and things like that that can abstract from your front end, back end, or edge and really clean up all of those tags before they hit the UNS. The other one is you've got the historian module installed here. In this example, we're using the Timebase Ignition module to get the data to Timebase historian. We're also using the OPC server here as a source of data for Flow software proper. So instead of you'll notice here that we are going straight from the tag gateway to the Timebase historian, rather than using a collector off of the broker. For most of our data on a site that we would use this architecture for, it's going to be coming from PLCs or instrumentation or other controllers at the edge through our Ignition Edge infrastructure here. So that allows us to have the fewest steps between the data and the historian possible. There's nothing stopping us from also putting a Timebase collector over here and sending that to Timebase as well. But for the sake of this, we don't have that. We're just going off the OPC server. The general intent would be if data is coming from the broker, we come through the tag providers in here and use this to help model the data for consistency and contextualization a little bit before it gets to Timebase historian. It just keeps things cleaner, keeps things more unified, has fewer pipes to pipe data through, and just kind of keeps things clean. Especially now there's the Ignition module off the Ignition historian functions, then we can also start to use that as a historian source as well. Flow software itself will have access to the OPC server within the Ignition tag gateway. It will have access to the Timebase historian and the backend Ignition database, depending on what we do or don't want to put in there, as far as maybe an MES database or anything else that could exist for the backend functionality. Flow will have access to that as well. And then Flow can also write the data back into our database as well as back into the OPC server on our backend gateway, which can then condition that data, have all of our functions and our backend functionality, SQL queries, Flow software KPIs coming through here to be cleaned up before they're funneled back into our proper Ignition tag gateway for everybody to use. Yeah, that's a good way to look at it. Yeah, and because it also has the separation of concerns now here too. In the future, if you have a larger rollout and you need more front end gateways because of prospective resource utilization, we can just start adding in more gateways there, horizontally scaled. We could add more backend functions if needed, and I would always kind of try to keep to one tag gateway as possible, but at some point you might scale out of there when you hit the millions of tags. So you could have more gateways as well. Flow software above here is just representing its backend database. Currently, it requires it to be Microsoft SQL. So that is a separate database from the Ignition infrastructure. Depending on how you architect it, this could be the same database server as some other stuff. Say you have Kanoa or something that requires Microsoft SQL Server. But we have Postgres and SQL Server here anyway because HiveMQ likes to use Postgres. And myself and most of the developers prefer Postgres as well. So outside of Flow software, we're using Postgres for most of our data stores.
So I would think that this architecture would cover like 90% of enterprises, but the missing piece here is like once you start, where would you start thinking about GraphQL databases?
Yep. So then that brings us to the difference between Graph databases and GraphQL as an API endpoint. GraphQL as an API layer, you might have a service somewhere that does GraphQL in the architecture. Currently, we don't. But if you had a graph database or you were looking to have a graph representation, maybe you're doing a knowledge graph or an ontological layer or something, then that could sit off of this tag gateway. It could sit on the other side of the broker, depends on where you need in the architecture. Probably more of an enterprise function, but possibly have something on the edge as well. Maybe Timebase Atlas, when that releases, will sit pretty well over here. But because it's not released yet, I haven't put it on the architecture because exactly where it fits will depend on some details that we don't yet know. But then once we do get Timebase Atlas or anything like it on the edge, that will enable MCP servers and things like that. And that again gives us one nice tag gateway to reference for any MCP functionality or knowledge graph pieces. It has one backend source for all of our tag values. We don't have to go to any specific Ignition gateway. We're not constrained to just MQTT. We have it on the OPC server as well. But if we have things that want to use MQTT, we can still publish all of those tags out over flat MQTT with some scripts or Sparkplug to the local broker and then break the Sparkplug topics out with a different function on the edge here in the UNS. And then that gives you the options from there.
Okay. Now, once you start thinking about publishing to cloud data warehouses and data lakes, what are your thoughts there? Like, when do you use CirrusLink? When do you use, time-based bridge?
Yeah. That's going to depend on the larger architecture quite a bit. That gets me to a different diagram. But the next step off of this is when we want to get to a data lake, a data warehouse. Maybe you want to get into some enterprise business intelligence layers or AI analytics in the cloud. Typically, at this point, we would do a HiveMQ cloud broker and then use their bridging functionality to do it. And then once you're in the cloud, you can do whatever you want from there. There's all sorts of stuff. Then you can pipe that into BigQuery. You can pipe that into Azure. You can pipe that wherever you want and use various tools depending on the company you're working with is probably going to have their preferences on there. So we don't really specify too deep into that layer. That's kind of IT always has their preference and usually it's good enough.
So IT would choose whether or not they use Snowflake, Databricks, or Microsoft Fabric. But how would you choose, let's say, Dylan, you're the architect and I'm the customer. Do I pump data to, let's just say, Snowflake? Do I use the HiveMQ publisher? Do I use CirrusLink inside of the Ignition tag gateway? Do I use time-based bridge? Which one should I pick?
So if it's me in a vacuum picking this, the easier options to integrate with some of this edge software, the industrial software stacks here, is Snowflake. And I would probably, in the HiveMQ cloud broker, use HiveMQ functionality to pipe that into Snowflake from there. That way we have one pipe for the enterprise, more so than one per site, and it gives us the least amount of connections in and out of that site possible. The more communication steps you have, the more protocols going in and out, and the more connections you have to the general internet, the harder it's going to be to secure, and oftentimes the harder it's going to be to get past the CIO to get approval for these architectures. As far as the payloads go on MQTT, it's typically going to be some form of a JSON payload. Exactly how that looks is going to be different for each enterprise. Different IT teams and different data warehouses, lakehouses, different piping streams, things like that, different ETL layers will all have their preference on how that looks to some degree. But generally speaking, it's going to be some form of standard data model that you have for each type of asset or each function or method that you can represent as JSON in some way or another. That might also be, typically speaking, I try to map that as one-to-one as possible in the UDT structure. So anytime you'd have a nested object in your JSON payload, I'll have a nested UDT in Ignition. And once you have that data model figured out and standardized, it's pretty easy to make UDTs in Ignition that map one-to-one to those JSON objects. And the rule of thumb there is kind of anytime you have a nested object or array in the JSON, that usually represents itself pretty well as a nested UDT or a nested structure of UDTs under parent UDTs. The line in the sand comes in where this is intended for a site level infrastructure. Almost everything we do in this architecture is going to be part of the what's often called blue namespace. Once we start getting into the red namespace, then we're going to need much more structured, much more common data models. And that's where, typically speaking, for me, that's the stuff that we do in the cloud at the enterprise layer. So if it's in Ignition, we're still using a lot of the same methods and keeping data clean and doing some data ops in Ignition. But once we get higher up into the stack, the level of standards that are required for a given organization get looser the closer you get to the ground. And the higher up, the closer you get to the ERP, the more standard and structured your data has to be. And the closer you get to the controllers, the more fluid and unstructured it needs to be to accommodate the various realities and devices and methods that people have on the field. So this is very much intended as the local stack for layer 2 to layer 3, SCADA to some overlapping MES functions in a way that can be fluid and customized per site before it gets to a much more standardized MES. So once we get to multi-site, you could have something like this, where you have HiveMQ, and we have the exact same infrastructure over here on the left, but on the right, you can kind of see an example of a potential enterprise architecture. The gray boxes are a little bit more abstract because they're going to vary depending on site, no matter what you do. Like this is probably going to be ETL more specifically. It might be HiveByte in some cases. It might be MuleSoft in others. It might be HiveMQ. Pipelines, it might be a lot of different things. But this is kind of the multi-site architecture up here. This is your enterprise layer. So you might have multiple local brokers, multiple instances of the stack on the left for each instance of this you have. Depending on the scale, this might look like a single broker for a single enterprise if you only have 10, 15 sites, or this might be a regional architecture that then consolidates even further up one more level if you've got hundreds of sites and multiple regions to manage and maintain. That could also start looking like, when you get into other things, maybe we don't have MQTT at all. And this is a little bit outside of the traditional UNS architecture, but we have a very, very similar stack on the edge here. The difference here now is we have the Fuse gateway, which brings us into our enterprise-grade MES layer. We no longer need an ETL layer between the ERP and Fuse because Fuse handles all that natively. Fuse can then get the data to the data lake and AI and ML, BI tools, all of that, and then any other APIs and things can integrate directly with Fuse from there. You may or may not still want a MQTT broker at this level, depending on some details and your exact architecture, but you don't technically need it for some. But if you look on the left-hand side here, this is all very largely the exact same stack. That said, with the Fuse side on the right here, the Fuse gateway is on-premise. The Fuse box over here is in the cloud in your own tenant. This gateway can connect not only to this Ignition stack that we have decided can hit almost any use case, but it also can connect to a legacy system. Maybe you have a plant pack site, or you've got a legacy Wonderware application or something like that that you don't want to change. So now you have a independent architecture that can exist on any site you need. Go through the Fuse gateway to Fuse, or in the other architecture option, go through the UNS to the actual enterprise UNS, and that then decouples your site from your enterprise. That then decouples your site from your enterprise app architecture. which allows you to have different architectures for each site. So in the case of mergers and acquisitions or brownfield sites that aren't quite ready or in the budget to upgrade, you can still make use of those sites at the enterprise level on the very standardized red models over here. Well, then on your lighthouse or your pilot sites, you can have your local stack over here that really proves that value for your next phases and your big rollouts. It's all about options. It's all about keeping things clean. This also gives you the ability to separate not only technically, but politically your stack. So your enterprise stack up here is very IT friendly, very standard, very political in some cases. But you also have this stack over here, your blue namespace in traditional UNS language, which allows you to innovate rapidly on site as the frontline worker or as the integrators working for the site. So this allows you to move fast and break things without breaking things. Yeah, we've got our website, abelara.com. I'm Dylan Dufresne on LinkedIn. You can find me there, pretty active. Reach out on the Discord. I'm on the 4.0 Discord, the Industry 4.0 Discord. And yeah, not hard to get a hold of. Happy to help. And we offer workshops on how to architect these types of things and how to get architectures like this, but modeled more for your independent needs with more nuance and things like that. Some examples of other versions of architectures is maybe you don't have the budget for Flow software. Same architecture, just without Flow. You've still got the Timebase historian. We could add Flow tomorrow. There's no reason why we can't have phased approaches to some of this. As a true SCADA layer, we can delete both of these, and now we have a world-class SCADA system. Now we have a UNS, and now it has a historian. And you could phase those approaches in feature by feature. Everything is additive. We have very little to no technical debt as we go because we hit features in a very targeted way. Say we don't need a whole SCADA layer. Maybe we just need some on-site data ops and data aggregation and collection. We can use Litmus Edge to connect to all of our assets, do some on-premise machine learning and AI algorithms, things of that nature. Connect Litmus Edge right to our Fuse gateway. And just because this site doesn't have Ignition, all the other sites that are attached to this same Fuse tenant here might have Ignition, they might have Wonderware, they might have anything else. It's all about keeping doors open. All of them can be used with MaintainX. Data can get back in, whether it's on Litmus Edge or Ignition Edge or Ignition proper. You could do the architectures like this, where you have very similar, same architecture here, but instead of Ignition Edge, maybe we have a bunch of controllers that Ignition doesn't have drivers for yet. We can then use Litmus Edge as our device connectivity suite with all the features of Litmus Edge. We can also then connect Litmus Edge to our tag gateway, and then from our tag gateway, everything's the same. So the key is going to be, we offer workshops to help you decide which of these, if any of these, are best for you and how to massage these types of architectures to meet your needs and the reality on your plant floor. Because every architecture is going to be different on every site. That's why the left is fluid. And that's why we only had 2 different, maybe 3 different options on the enterprise side that really work for this. But on the site side, there's 100 different ways you can configure it. And even within the same enterprise, no 2 sites are going to look the same. Yeah, so an initial workshop with us, an initial engagement is typically a discovery phase. We work directly with your leadership team to identify your pain points, try to understand the root cause of the problems you're facing so we can hit the root cause, not the symptoms, and really solve your problems. And then once we've sat down with your leadership team, site level leadership, center of excellence, enterprise teams, what have you, then we can sit down with 1 or more technical teams, depending on the size of the engagement, and hear the same story from them. What does the technical team think the limitations are? What pain points are they experiencing? Then we bring all of those back together. We've spent some time really learning your process, your equipment, your machines, and then based on our understanding of your process and your equipment, your technical team, their needs, and your leadership team and their needs, we combine all of that into a recommended architecture that we believe will allow you to move fast and get started. There may be changes that are needed in the future, but our intent is to get you something that's going to work with minimum technical debt, but keep you moving. Our goal is to get you unstuck, get you out of analysis paralysis, take the 1,000 different logos and software packages that you have been trying to decide between, and get you a list of 3, 5, maybe 10 max that will solve all your problems in concert together. For our typical engagement, it's about 15 to 20,000 for our typical upfront engagement. That is the discovery phase. That is multiple workshops with your leadership team, your technical team, and a deep dive into your architecture. And then a report and presentation and discussion around how you could implement that tomorrow. From there, phase 2 can commence. And that's where we will either work with your internal team to build the skill sets up to work on this stack, or work with your local integrators or suggest an integrator who can help you deploy. We are not an integrator. We are here to coach, consult, and train your team on the skills and culture needed for true digital transformation. And with that, not being an integrator allows us to go wider, to spread further, and to help more people. We have partners who are integrators who each have their own specialty in different verticals, and we are more than happy to recommend you who we believe is the best integrator in your industry. If you want to subscribe to the channel, there's a notification button below. You can subscribe, like, and stick around. In videos coming up, we are looking to do a combination of technical demos, deep dives into specific applications, specific use cases, and common cultural problems. Really want to get you the skills needed to solve your own problems.